We have a few more minutes left, and I'd like to start 3.3. 3.3 deals with rational functions and other functions. Same thing, graphing. 3.3, rational functions and other functions with asymptotes. Rational functions are not the only ones that have asymptotes. There are others, other functions. Okay, so what is an asymptote? So there are three types of asymptotes: vertical, horizontal, and slant. These two can go together. These two can go together. These two never. The slant and the vertical can happen at the same time. The vertical and horizontal can happen in the same function. But horizontal and slant can never happen in the same function. So let's talk about these two, which are very common. This is slightly different. So page 7. So here is a vertical asymptote. We've seen them before many times. Let's say x equals 2. And the function left and right can do this, can do this, but not both, or can do this, but not both, right? In other words, I'm saying the vertical asymptote can have the function on both sides going to infinity, on both sides going to negative infinity, or opposite. So this is a vertical asymptote, VA. In this particular example, y equals 0 is a horizontal asymptote. So y equals 0 is a horizontal asymptote. How come? As x approaches infinity, the function values get closer and closer, closer and closer to 0. As x approaches negative infinity, the function gets closer and closer, closer and closer to 0. So here, that's why this function should not even be in 3.2. Here, this is a horizontal asymptote, but not at this end, only at this end. So only when x approaches negative infinity, the function gets closer and closer to a horizontal asymptote, which is y equals 0. Okay, so what is a slant asymptote? A slant asymptote is exactly what it says, oblique. Something like this. This is a slant asymptote. And what will the function do? Follow it. The function follows the asymptotes, follows the asymptote, follows the asymptote, follows the asymptote, follows the asymptote. So this will be a slant asymptote, vertical asymptote, horizontal asymptote. Okay, so let's at least start one example from what is my book? From here, in which we're not graphing just yet, but we're asked to determine the vertical asymptotes of each function. So let's choose a function from here, from 1 through 8, and we will find vertical, and we will also find horizontal.
Can we use 7?
You said 7?
Yes.
Is that okay? Perfect. So let's take a look at 7. So 7 is f of x equals x plus 2 over x squared plus 6x plus 8. Perfect pick. You'll see in a moment why. So remember, In math, we always look at simplify, factor. In other words, make my life easier. That's what it means. So when I look at this function, I realize that the denominator is factorable. How do I factor a denominator?
X plus 2, 4, and x plus 2.
Very good. I have to state restrictions first before I simplify if it's possible. What are the restrictions for this function?
-2, 4.
Very good. So remember the domain of this function is negative infinity, negative 4, union negative 4, negative 2, union negative 2 to infinity. Now I am allowed to do this. Only after I stated the restrictions, I am allowed to simplify. Good. So then the function reduces to a very nice function. Very nice. So which x value is not allowed? Well, negative 4. Well, x equals negative 4 is a vertical asymptote. But what about x equals negative 2? Anyone remembers when the factor disappears, what does that represent? The function is still not defined there. Even if the factor disappeared, it's still not defined. But if it's not defined but the factor disappeared, what is that? What happens at that point? Anyone remembers? What happens at the point where the factor disappears but the function is still undefined? Yes! At negative 2 there is a hole. How do I find this number? Plug it in the simplified form. Thank you so much. Who was that? So when I plug in negative 2, was it Cece?
It was Samantha.
Samantha, thank you so much. Negative 2 plus 4 is 2. So then this is 1/2. So the whole is negative 2, 1/2. Awesome. Thank you, Sammy. Perfect. So we're asked to find vertical asymptotes. We did. I also want to find the horizontal asymptote if there is one. Yes. F of x equals 1 over x plus 4. To find horizontal asymptotes, we find the limit as x approaches infinity and limit as x approaches negative infinity for 1 over x plus 4. Can anyone tell us the limit? Of course, it will be the same. It's a rational function. Can anyone tell us the limit of 1 over x plus 4 when x approaches infinity?
Is it 1?
Careful. $1 divided by billions of people. When I come to your door, how much is left from that dollar? How much can I give you? 0. Exactly. So that's why y equals 0 is the horizontal asymptote. Exactly. That is always easy. Small over huge. The limit will always be 0. Small over huge. So for this function, we found 3 different things. One that we were not asked for, but we found it. A hole. We have found a vertical asymptote. And we found a horizontal asymptote. It's intentional. That's why they put it in there. Factorable and simplifiable. Because they wanted us to fall into the trap and say, oh, x equals negative 2 and x equals negative 4 are vertical asymptotes. No, they're not. Because this factor disappears. It can no longer be a vertical asymptote. If I had here x plus 1 and I could have not simplified x plus 2, then x minus x equals negative 2 and negative 4 would have been vertical asymptotes. But the moment this factor disappeared, negative 2 comma 1/2 became a hole. So there is only one vertical asymptote and there is one horizontal asymptote. So for the horizontal asymptotes, that's all we need to do for any function. Find the limit at infinity. That's for the horizontal. For the slant, we're going to talk about it on Wednesday. We're going to look at an example. I will not test you on slant, but I want to show you an example.